Hello, welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences ITB. So today we are going to discuss limits, continuity, and derivative. First of all, we will look at the limit. Okay. Now, why do we need limit? Limit is not needed when we deal with good function such as polynomial. Limit is not needed when we deal with function that is familiar to us since in junior or senior high. Look at this function. The domain doesn't include x equals 1. But what happens to the value near x equals 2? To determine the condition or value near x equals 2, we need limit here. Then what about when we combine function? Let fx be x plus 2 and x squared for x less than or equal to 1 and x greater than 1. The function x plus 2 and x squared are good function in a sense. It's always defined for any x in real. But what about the condition or value when the function changes, such as at x equals 1? In this case, also we need limit also in. So let's look at the limit. The limit for the function that is good, in a sense, the limit of a function f at x equals c is the same as the value of f at x equals z. So if we want to find the limit of this, when x goes to 2, we can just substitute x equals 2 and you have equals 2 plus 2 equals 4. What about this one? This is divine for x near 2 because the denominator is not defined when x equals minus 2. The rational function is not defined when x equals minus 2. So when x equals 2, it's okay. So this is just a good function near x equals 2. So I can substitute. So I have 0 divided by 4 and 0 divided by 4 is just 4. So for function that is good in a sense, the limit of f is the same as the value of f at x equals c. Okay. What about this one? It is not divine when x equals 2. So when we want to find the limit at x goes to 2, we can try to factorize it. Then try to solve it. So I have this. So I factorize x squared minus 4, x plus 2 times x minus 2 divided by x minus 2. Don't forget, when we are talking about limit, we are talking about the condition or the value of this function near x equals 2, but not at x equals 2. So I don't care about what happened at x equals 2, but the limit is just dealing with x near 2, in the neighborhood of 2, but not 2. So I have x minus 2 divided by x minus 2. This cancels out. Why? Because x is never 0. X is never 2. So you don't have 0 divided by 0, which is undefined. So you have, it cancels out. So you have x plus 2. This is just the same of this. And you can plug in x equals 2. So you have 2 plus 2 equals 4. Okay. So there is a fundamental equation that have to be asked before we are looking at the limit on a certain point. That is, do the limit exist? Do the limit exist? The kind of question should be asked before before what is the value of the limit. Do the limit exist? If it exists, what is its value? Now we will look at the meaning of the limit exists at a certain point. Okay, the limit of function fx exists at x equals c if and only if the condition or the value here in the neighborhood of x equals c, the neighborhood, it means that on the left and right hand side of c, on the left of c and on the right of c. So if the condition or the value in the neighborhood of x equals c is the same, in the left and the right is the same, I don't care about x equals c for the limit, then the limit of function exists. Okay, then we define the left hand side limit. This is limit of fx when x goes to c minus, if we let x equals 1. So I want to know the value of f at x when x goes to 1 from the left of 1. That is, what is fx at x equal 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 0, 99, 0, 999. Near 1, but from the left. And this one, the right hand side limit of fx, x goes to c plus, let c be 1. So 1 plus, it means I want to know the value of this when x goes to 1 from the right of 1. That is 1, 1, 1.05, 1.005, 1.0005. What happened to the function? What happened to the function? So I want to find the limit. So if this result, it says that if this limit and this limit exist and they are all the same, then the limit of a function fx exists at x equals c. Okay, yeah. So let's look at this example. Determine if limit fx when x goes to 1 exists. This is the combined function. So it could be some problem at the when the function changes. That is when x equals 1. So we are looking at the limit of fx at x goes to 1 minus. 1 minus is the left of 1. Left of 1 is this one. So I have to substitute this rule, the first rule. So this is the same as limit x goes to 1 minus of x plus 2 and x plus 2. So it's okay, it's a good function, so I can just substitute. This is 1 plus 2 equals 3. What about limit fx where x goes to 1 plus? That means on the right of 1, this one. So I have to choose this rule. So I can plug in fx become x squared. This is good function. I substitute 1. This should be, I'm sorry, this should be 1 squared. 1 squared is 1. So I look at the limit of fx on the left of 1 is 3. The value of f near x on the right of 1 is 1. So I have the limit, the left hand side limit is not the same as the right hand side limit. So I can conclude that the limit of f at x goes to 1 doesn't exist. Okay. Okay, this is some remark. The left hand and right hand side limit of a function at a certain point determine the condition, or I mean the value in the neighborhood of that point. Not on that point, just in the neighborhood of that point, in the small neighborhood. Okay, later we will discuss about the continuity. Thank you.